Unit 2, Lesson 3. This lesson aligns with 14.3 in your textbooks. The one standard we're going to discuss: prove the Pythagorean identity sine squared theta plus cosine squared theta equals 1, and use it to find sine of theta, cosine of theta, or tangent of theta, given the sine of theta, cosine theta, or tangent of theta, and the quadrant of the angle. Here are some common basic trig identities. I would not write these down. If you go to Google and type in basic trig identities, you can get a whole sheet that has all the trig identities listed out, and I would just print that off so you don't have to write all these down. These are the ones we're going to work with the most: the reciprocal identities, quotient identities, the negative identities, Pythagorean identities. We're going to focus on this in this lesson, and cofunction identities. Now we're going to go through a proof of the Pythagorean identity sine squared theta plus cosine squared theta equals 1. So if we start with the unit circle, we have the x-axis of the coordinate plane, the y-axis. I can construct a right triangle just like we did in the last lesson with the unit circle. Construct a right triangle. We know the radius is 1. We have our y and our x values and our angle theta. Just looking at this right triangle, we can use the Pythagorean theorem. X squared plus y squared is equal to 1 squared, and we know 1 squared is 1, so we can ignore that part. Using SOHCAHTOA, we can also write some trig ratios. If I'm looking at angle theta, the sine of theta is equal to opposite over hypotenuse, y over 1, which simplifies down to just y. We also know that the cosine of theta is equal to adjacent over hypotenuse, so x over 1, which simplifies down to just x. What we need to do now is substitute these equivalent values in for x and y in our original equation. So cosine of theta is equal to x. So up above, I can replace or substitute cosine of theta in for x. And I can do the same thing with y. I'm going to substitute in sine of theta, that equivalent value. Now cosine of theta squared, the standard way to write that is cosine squared theta plus sine squared theta equal to 1. This is our most common form for the Pythagorean identity. And recall from the last lesson that I said that the sine of theta, when we were looking at the ordered pairs on the unit circle, sine of theta corresponds to y, which we can see down below. Cosine of theta refers to x. And now you can understand that a little more because of this right triangle in the unit circle. Now looking at this next screen, right now it's going to look like a bunch of gibberish, but I'll go through and explain what all this means. Referring to our x and y axis, we have the 4 quadrants, quadrant 1, 2, 3, and 4. And now we have a saying that you need to remember. All should take calculus. We have A, S, T, C. The A in quadrant 1 refers to all trig functions are going to be positive in quadrant 1. So sine, cosine, tangent, secant, cotangent, all of them are going to be positive in quadrant 1. In quadrant 2, the S stands for sine is positive, which means the reciprocal of sine, which is cosecant, is going to be positive as well. So in quadrant 2, sine and cosecant are positive. All the other ones will be negative. Quadrant 3, T, is referring to tangent being positive, which means its reciprocal, which is cotangent, will be positive as well. The other 4 are going to be negative in quadrant 3. Quadrant 4, the C, standing for cosine, and its reciprocal, which is secant, are going to be positive. The other 4 trig functions will be negative. So all should take calculus. Make sure you have an understanding of this because we're going to use this next. In this next example, we're going to use the information to find the missing trig ratio. If the cosine of theta is equal to 12 over 13, and theta is between 0 and 90, we want to find the cosecant of theta. Okay, so if theta is between 0 and 90, we know it's in the first quadrant. So by that, we know cosecant must be a positive value. We can construct any basic right triangle where we have theta, and now we're going to fill in the information we know. We know cosine is equal to the adjacent over the hypotenuse, so 12 over 13. We would need to find this y value. Okay, so using the Pythagorean theorem, a squared plus b squared equals c squared, you could go through 13 squared is equal to 12 squared plus y squared. If we would subtract that over, get 25 is equal to y squared, thus y is equal to 5. Using this information now, we can go through and find the cosecant of theta. You might not remember the relationship of cosecant, but it's the reciprocal of sine. So if we have the sine of theta is the opposite over the hypotenuse, the reciprocal of that would be the hypotenuse over the opposite. So cosecant of theta must be equal to 13 over 5. So knowing that our theta value is between 0 and 90, that means we're in the first quadrant. All of our trig ratios are positive in the first quadrant. Create a right triangle, solve for the missing side, use ideas of SOHCAHTOA to find the relationship for cosecant. Next example, we're going to do the same thing. If secant of theta is equal to negative radical 15 over 3, and theta is between 90 and 180, we want to find the sine of theta. If theta is between 90 and 180, we know we're in quadrant 2, so our sine value is going to be positive in quadrant 2. We can create a right triangle again. If we're in quadrant 2, we're going to have our right triangle facing this way. Now we have to think about the relationship of secant to the side lengths. Secant is the reciprocal of cosine. Cosine is the adjacent over the hypotenuse, which means secant is the hypotenuse over the adjacent. So our hypotenuse is radical 15, and our adjacent side is negative 3. Okay, I know when dealing with triangles and distances, we can't have a negative value. This negative 3 is just referring to going to the left on the x-axis. Okay, it's referring to a direction in this case. Again, we need to find what this y value is. Using the Pythagorean theorem, radical 15 squared is equal to negative 3 squared plus y squared. Radical 15 squared is 15. Negative 3 squared is 9. So 15 minus 9 is going to give us 6 is equal to y squared, which means if y is equal to radical 6. So the side length is radical 6. So now having this information, if we're looking for the sine of theta, the sine of theta is equal to the opposite over the hypotenuse. Thus we have sine of theta is equal to radical 6 over radical 15. Neither one of those radicals can simplify, so it's fine to leave that as our final answer. And we know that's correct because we said in the beginning sine had to be positive in quadrant 2. Some of you may be confused on how I constructed that triangle. It may help you to think of the coordinate plane. We have our x-axis and our y-axis, quadrants 1, 2, 3, and 4. Since we were told theta was between 90 and 180 degrees, I could determine from that we are in quadrant 2. All right, and when I'm in quadrant 2, I want to, or whatever quadrant I'm in, I always like to construct my triangle so that the right angle is located on the x-axis. That's why when I constructed my hypotenuse, I brought it down this way so that my right angle was on the x-axis. Some of you may have constructed, I did the hypotenuse, could have gone over here, constructed your right angle this way as well. Technically, that will work. You still have your hypotenuse, you have your y value, and you have your x value. I just prefer, that's my own preference, to keep it located on the x-axis. Okay, so going back to what we had, got our right triangle. We are told secant of theta is equal to negative radical 15. When you're constructing the hypotenuse, this value is always going to be positive. Okay? The only negative values are going to occur with your x or your y. And since we're in quadrant 2, y refers to the sine value. Sine is positive in quadrant 2. Also, if we're starting on the x-axis and going up, that's a positive. The reason we're negative is because we're starting at the origin and going to the left. That's why we had this negative 3 value in this problem. Okay, this is still probably going to be confusing for some of you. Don't worry, we'll practice it more in class. The main identity I said we were going to focus on in this lesson was the Pythagorean identities. We've talked about one, the main one, sine squared theta plus cosine squared theta equals 1. There's 2 other forms, and now we're going to go through where they come from. If we take this base Pythagorean identity and divide the whole equation by sine squared theta, well, sine squared theta divided by sine squared theta is 1. Cosine squared theta divided by sine squared theta, if we go back to the beginning and look at the quotient identities, cosine divided by sine is equal to cotangent. So if we take cosine squared divided by sine squared, that is going to be equal to cotangent squared theta. And then 1 divided by sine, if we go back and look at our reciprocal identities, 1 divided by sine is equal to cosecant. So 1 divided by sine squared theta is going to be equal to cosecant squared theta. And this is one of our other forms for our Pythagorean identities. 1 plus cotangent squared theta is equal to cosecant squared theta. We're going to use a similar process to go through and figure out how to come up with the other one. If we take our base Pythagorean identity and now we're going to divide the whole equation by cosine squared theta. Sine squared theta divided by cosine squared theta is tangent squared theta. Cosine divided by cosine is going to be 1 equal to 1 divided by cosine squared theta. Go back and look at the reciprocal identities. 1 divided by cosine is equal to secant. That means 1 divided by cosine squared is going to be equal to secant squared theta. Going back and looking at our identity sheet again, tangent squared theta plus 1 is equal to secant squared theta. So that's how we can show where all 3 Pythagorean identities come from. The one we're going to use most often, sine squared theta plus cosine squared theta equals 1. From this lesson, make sure you understand the proof for our basic Pythagorean identity, as well as go through the process of finding the other 2 forms. We'll go through more problems in class of given a trig ratio and where angle theta occurs, we can determine the quadrant as well as construct a right triangle to help us find another trig ratio. We'll go through more of those problems in class together.